Hi, Pre-Calculus. We're back with 111 notes here, and this is just continuing on from what we did in class with 110. So same work page or note page, and we're going to just start with let's call it example 2, but it was the first example on there. Most of the classes got at least most of the way through this one. We'll just start here again and do the rest and get into all the other examples. Um, I did record the definitions again. Didn't work out from the recording during class. I don't know why. So I recorded those and put it on a separate one. No questions pop-ups during that one. It'll just be for your reference if you need it. So look back at that if you want the definitions for all the vertical, horizontal asymptotes, holes, all that kind of stuff that we're looking at. Okay, let's get into um, graphing these without a calculator. And this is our example, number 2 to start out with. So like I said, most of us got all the way through this in class, if not just most of the way through, almost finished at the end. So good review for us. All right, first thing we want to do on this one is we are going to factor. So we want to look at factors. That gives us a lot of information for these, and we'll review the definitions as we go through each one too. So factor, we've got x times x minus 2, we've got a common factor there, over x minus 4 times x minus 2. Looks like the x minus 2 is going to cancel out. So that tells us right away, holes. Something cancels. So that's why we factor right away. We can find these things pretty easily with a lot of factors. So let's start with the one we canceled out. There's a hole. And that hole is at ordered pair. 2 is the x value. Remember, y value, we want to plug into what's left. So x over x minus 4 is left. That's going to be 2 over 2 minus 4. That's negative 1. There's a hole, and I'll just put it on the graph over here. At 2 comma negative 1, make sure you put an open circle on your graph. All right, that's a point we can use to go through on the graph as well. It's just an open circle point. All right, we have x over x minus 4 left. Everything else we do can come from that smaller function. So just pay attention to that one here. Vertical asymptotes, there's still a denominator. Always x equals for the equation, and we have 4 in that x minus 4, so x equals 4. Let's put that one in here. So at x equals positive 4, we're going to have this dotted line vertical asymptote in there. All right, that's going to help us guide our line as we get close to it. We have to follow the line up or down on the vertical asymptote. Horizontal or slant asymptote. We have to compare degrees for this one. And this one, the original problem has squared on top and squared on the bottom, same degree. So ratio of coefficients was the rule. And this is a 1 over 1 for the coefficients. So horizontal asymptote is what we have. And that is always y equals the number, and 1 over 1 is just 1. So we have a 1 for a horizontal asymptote, and we will put that one in with a dotted line there. Also, another guideline for us to follow. So same degree. Now, if you look at x over x minus 4, those are the same degree also. It's still there, first degree and ratio of 1 to 1 for the coefficients. So you can always use that smaller one. X-intercepts. We've got x-intercepts, plug in 0 for y. 0 equals, and it is just the numerator. So 0 equals, the numerator is just x. The x minus 4 on the bottom you can forget about, and we reduce the other part. So 0 equals x, that's 0, 0. And put in 0 for x and see what you get for y for the y-intercept. Well, 0, 0 is on both, so it's going to be there as well. 0, 0. But 0 is pretty easy to plug in anyway. All right, that is 1 point for us. We get right there. All right, there's all of our information labeled on here. We might need a little bit more as we graph, and there's a lot of little guidelines that we have to pay attention to. So I'm going to talk about a lot of things you can use to check kind of the checks and balances of graphing rationals. A lot of stuff should always work together, and some of it you've worked with before. All right, so I'm going to start graphing with these 2 points and just connect them in between. So this graph looks like it's leaning down as we go towards the vertical asymptote. So I will continue that down as best I can draw on here. All right, next to the vertical asymptote, it goes down. That's part of it. Now, why didn't it turn around and go up? One reason is, here's one of the checks and balances. We have an x-intercept right here at 0, 0. That is the only x-intercept we found. There are no more. So one thing we know about x-intercepts is once we found all of them, we can never cross the x-axis ever again. If we turned around to go back up next to the vertical asymptote, we would cross over the x-axis. We can't do that. So one thing we want to check on this one, check is one x-intercept. Now, it's okay to have more than one, but we would have found it. We only have one. So we can never cross the x-axis anymore. That'll help us. All right, now I need to go on. Let's see what happens as we go off to the right. It looks like we have to get close to the horizontal asymptote, and it's going in right that direction. So it looks like that would make sense. Here's another thing that we can do. We can still think of bounce, wiggle, cross. That x-intercept comes from x. That's to a first power. That's a cross. It crosses through the x-axis. Still works just like it did before. So it crosses through and it gets close to the horizontal asymptote. Use that guideline. All right. So we found our graph, this curve, on the left side of our vertical asymptote. Can't have anything above because that wouldn't be a function. Okay, we can only have one piece either on the top or the bottom. So we have to think of what's happening over here on the right side. We don't have any points on this. So one thing is you can always find other points. Okay, if you want to plug in a point over there. So I'm going to do a little XY chart. And if the asymptote is at 4, I'm going to plug in a 5 because usually that makes the denominator 1. 5 minus 4 is 1 on the bottom and 5 on top. It's 5 comma 5. I'm just plugging into x over x minus 4. So 1, 2, 3, 4, 5. That pretty much tells me where my graph is. It's going to be above here. Let's think of the other reasons why it has to be above. First check. 1 x-intercept, no more in this problem. If I was to draw a graph on the bottom, it looks like to get close to the horizontal line, I have to cross through the x-axis again. Can't do that, so I'm not going to go to the bottom. There's another reason here it has to be at the top. Let me draw this in. This is where we're going to be. There's our graph. And it has to do with the vertical asymptote. We already know it's at 4, but check the vertical asymptote exponent. Okay? And that is similar to the bounce, wiggle, cross. Just like the exponent on the x-intercept told you we cross through. Well, same thing here. The exponent, if it's odd, that's like a, well, cross and wiggle are both odd, but it goes through the axis, right? What it really means is you change sides of the x-axis on those. So because our vertical asymptote here is at x minus 4, and it's a first power, that first power tells you the two arrows that we draw are going to change sides or be on different sides. Meaning if one goes down, the other one must go up. If that's a first power, we change sides of the x-axis, just like wiggle and cross do. They go touch and go through. This one's a vertical asymptote, so it just switches where the arrow is. If it was an even exponent, it would mean we're on the same side and they go the same direction. We'll see one of those. So there's a whole bunch of stuff we can use to check and balance everything and make sure it all fits together with the information we used. And there's our graph. Let's go on. Quite a few of these, so I don't want to make this too long for the video. All right, graph without the calculator, 5 over x squared minus 4. Let's factor 5 over x minus 2x plus 2. Nothing cancels, so automatically no holes. Vertical asymptote. We have x equals. There are 2 factors in the denominator, so it's okay. We are going to have 2 vertical asymptotes, one at 2 and one at negative 2. Let's draw those in. That means we have now split this up into really 3 sections. Okay, there's the left side and the right side we have to draw something on. Now there's the middle we have to do also. So don't forget about the middle. Horizontal and slant asymptotes. If you look at this one, compare degrees, no x's on top, x squared on the bottom, bigger on the bottom. So bigger on the bottom means horizontal asymptote and it is automatically y equals 0. Okay? Automatically, if more degree on the bottom, we have a 0. So the x-axis is a horizontal asymptote. Okay? All right, keep going here. X-intercepts. We got to plug in 0 for y, and we say 0 equals 5 over stuff. Remember, it's only the numerator. 5 never equals 0. So that means no x-intercepts. Kind of makes sense with what we think with that horizontal asymptote, but we'll see some weird things going on later in other problems. So 0 can never equal 5, no x-intercepts. Y-intercepts, let's plug in 0, and you get 5 over 0 squared minus 4. So that's negative 5/4 for the y-intercept. Y-intercept, let's see, negative 5/4. Right about, we'll just estimate on this one, right about there. That's the only point we have. So let's use that to try to graph now all the information. Remember those checks and balances we're going to do. So I have a point to go from. So as I get closer to each vertical asymptote, I have to decide, do I go up or do I go down? Remember the first check I told you to do. No x-intercepts on this one. Check how many you should have. That's all you get. We have none, so we cannot cross the x-axis. If we wanted to try to go up, we would cross the x-axis. So that means we have to point the arrow down on that side. Well, same thing as we go towards the other one. That means we have to point the arrow down. Otherwise, we would have to cross the x-axis. So there's this middle section in there with a point and both arrows going down. Well, we don't have anything on the right. We don't have anything on the left. Let's try some other things. We can find points. XY chart, I would plug in a 3 and a negative 3. If we plug that in, 3 gives me a 1. Plug it in 5 over, it'd be 9 minus 4 is 5. So 5 over 5 is 1, 3 comma 1, that's above. So I'm pretty sure my graph is up above here. Let's see if it makes sense with other things too. Vertical asymptote, x minus 2 to the first. Odd power, different directions. This side goes down, the other side must go up. That works out well with this point that we have. It's a real tight turn in there, and then level off at the horizontal. Same thing happens on this one. It's negative 3, 1, still 5 over 9 minus 4. So we have that point, and this x plus 2 is a first power, so we should change sides. One side goes down, the other side goes up. That bounce wheel across comes in handy in other situations too. So go connect, make a tight turn around, and out to the side. There's all the information right on that graph. Let's go to another one. All kinds of weird situations could happen. 3 over x plus 4 squared. Good news, already factored. All right, so it's factored. Nothing cancels, so we can say no holes. Vertical asymptote, we have a denominator. X equals, it's a denominator of negative 4. Is that 0? So x equals 1, 2, 3, 4. There's negative 4. Horizontal and slant, let's check. The degree on the top is 0, no x's. On the bottom, it's x squared, remember. It's the degree when you multiply everything out. So bigger on the bottom is horizontal asymptote, and it is y equals 0 again, bigger in the denominator for the degree. So y equals 0, there's our x-axis again. X-intercepts, put in 0, solve the 0 equals the numerator, denominator doesn't matter. That cannot happen, so no x-intercept. Remember that. We can never cross the x-axis now. So we have none. And y-intercepts, plug in 0, and we get 3 over 4 squared is 16. We're just going to estimate where that is. So we have to estimate real close, 3/16. We'll just put a point right about there. It's above the horizontal asymptote is an important thing. Okay. All right. That's what we have. Let's see if we can figure out where to draw the rest of this now. So it looks like it would be pretty easy just to use this point we have, the y-intercept, and say that's pretty close to the horizontal asymptote. I'm just going to use that and follow right above it. That seems good. I can't cross over the x-axis, and I have to follow the horizontal asymptote. As we get closer to the Vertical asymptote, I can't go down because it crosses the x-axis. So that must go up. Okay, there's a full side just from that one point and knowing it never crosses the x-axis. All right, our vertical asymptote is x plus 4, and it is squared. Even power means same direction. It's a bounce. It stays on the same side of the axis. So if one side goes up, the other side goes up. We're going to have an arrow up there. Well, that tells me I know where my curve is over here. You could find a point on here if you wanted to plug in, do a little XY chart and do -5 right next to it. I think you get a 3 when you plug that in. 3 over -1 squared is positive 3. So 1, 2, 3 right there. That confirms that we've got this point to go through and we aren't going to cross through, but follow the asymptote out. A squared vertical asymptote is a side-by-side graph. The two arrows go the same direction. It's going to come up a lot of times during the year, this even and odd, being same or being different. Okay? Same side or different sides. There's the full graph. All right? So we never cross the x-axis. We use the directions on here. We checked another point. All those things should always work together. Okay? Keep on going. Once we get some experience, these go a little bit quicker, as you see. Number 5, this one is almost like the last one, but we have x minus 3 in the numerator. It is factored. Nothing cancels, no holes. All right, so vertical asymptote, same thing. X equals -4. It is squared. Okay, so -4. And I'm just going to write down here we have x minus 4 squared. So I remember same direction on each side. So as long as I know one direction, I know the other one. Okay. Horizontal and slant asymptotes, first degree on top, but remember second degree on the bottom. X squared is what we get out of that. So denominator is bigger. Horizontal asymptote on this one, y equals 0. So still almost the same as the last one that we have here. X-intercepts, we plug in 0 for y, and we say 0 equals numerator. Doesn't matter what the denominator is, you can multiply to be 0. So x is 3. That's just the factor on top. We should know 3 there. So 3, 0. That's strange. There is an x-intercept. The x-axis is our horizontal asymptote. I thought in Algebra 2, when we were little kids, it said, don't cross the horizontal asymptote. That's not a real rule. The idea is the horizontal asymptote guides us the farther out we get. First thing is, it's not real important in the middle. So go ahead and cross the horizontal asymptote. There's even graphs that cross a horizontal asymptote an infinite number of times. So this one, let's put that 3 on there. Okay. Another thing to notice, that came from x minus 3 to the first power, so it should cross through that the x-axis. There's our bounce wiggle cross. So we're going to think of that. So right now I don't know really which way it's crossing through. Let's try a y-intercept. Plug in 0. We get 0 minus 3 over 0 plus 4 squared. That's -3 over 16. So just by plugging it in, -3 over 16 means we're on the negative side. It's just a little bit below. And we have 2 points now, and that gives me kind of a lean on this graph. We can lean one way or the other and see if it's going down or if it's going up. So there's all of our information. Let's see what that leads us to. So if I connect these two, it is leaning down. And remember, if I have to decide between down and up, if I go up, I cross through the x-axis again. Can't do that. There is only one x-intercept, and we have used it. So we do have to go down on that side. Well, we said this x-intercept is also a cross through over here. So that means I must go over. And here's what this one does. It crosses over, but then think of it like it bubbles up a little bit, but we have to follow this horizontal asymptote out. So it, even though it crosses over, it eventually just comes right back to the horizontal asymptote to follow it. Okay, so that is what is happening there. It did cross through and come back. All right, the other side. The other side, we need to figure out above or below. Remember what we said about this squared. That is same direction. If one side goes down, the other side goes down. So we already established the right. Now we have the left. So that means we're going to be in this section right down here. And if we want to plug in a point, we can. I believe if you plug in -5, you get -8. 2, 3, 4, 5, 6, 7. Right about there, we should have gone through. So that would have been a little bit more accurate. But you can always do a little point to see -5 gives us -8. That confirms that it goes down, that it's in this bottom section and not in the top. But that is the idea. Okay, so there's a couple with that squared. And we saw we can cross through the vertical asymptote. All right, let's see example number 6. Another thing that could happen to us. All right, on this one, we've got polynomials here. It looks like we should factor. So the top is going to be x. It's a +3 and an x minus 2. On the bottom, we've got 8 and 2. That's going to be an x plus 4 and x minus 2. Hey, lucky for us, cancel whole. The whole is at 2. And plug into what's left. 2 plus 3 over 2 plus 4, we get 5 over 6. Estimate where that is with an open circle. 5, 6 is close to 1. There is our whole. Vertical asymptote. We still have some left in the denominator right here, x plus 4, so that's -4. We'll put that one on. If I can draw here. All right. There's our vertical asymptote, x plus 4, and it's the first. Help me remember different sides. All right. That one, x plus 4, the first. We have some information there. Horizontal and slant asymptotes, same degree, x over x. Use either one you want. Coefficients 1 over 1. So horizontal asymptote, and it is y equals 1. Now the important thing here, look at where the hole is. The horizontal asymptote is at 1, and when we estimated that 5/6, it is below the horizontal asymptote. So make sure you get that part in. It's close, but it is below, and that's important. X-intercepts, put a 0 in for the y. If we put a 0 in, we solve the top. The top has an x plus 3 after we reduce. So that means it's just -3. Okay, just look at that factor. And that's a first power, so that means it's a cross through. All these things you can check with each other. So at -3, 1, 2, 3, -3 right there, cross through, okay? And there is only one, remember, one x-intercept. Y-intercept, plug in a 0, and you end up with 3/4. Now, here's a shortcut if you have a polynomial like this. All the x's turn to 0. Here's your y-intercept, -6 over -8, or right here, 3/4, because the x minus 2 is gone. So 3/4. There's the constants is what it is. So -6 over -8. Estimate where that is, 3/4. That is actually, that's lower than 5/6. It's above the 0. So that helps us tell just where this is leaning. Kind of makes sense that it's there. So let's draw this in. Looks like if we connect these, they are leaning down. And we cross through. There was a check. We crossed through at the x-axis to go down next to the vertical asymptote. And we just hit that hole, open hole, make sure it stays open. And it looks like we are real close, so we can follow the horizontal asymptote out. That horizontal asymptote at 1. We're just a little bit under it. Other side, the 1 right here, different, odd, different directions. So this one goes down, the other side must go up. And if you want to confirm, you can plug in a point. So -5 gives us +2. And just use the x plus 3 over x plus 4. Okay? So -5 plus 3, that's -2 over -1 is +2 right there. So we end up with that. We can't cross the x-axis over here, so it couldn't be below. The direction tells us it's different, and we found a point up there. All those things go together. Every one of them checks to make sure we did the right thing. All right. So all of those had horizontal asymptotes. We haven't talked about slant asymptotes yet. I said that we'd do that later. Here is later. Slant asymptotes. Now remember when it was. It said if the numerator degree is greater than the denominator degree. So this is where we're big on top. Okay, we're at the circus. We got the big top. It's going to have a slant asymptote. So bigger on top, we're going to have a slant asymptote. Specifically, now this really is a possible slant asymptote, specifically 1 degree bigger. That's what makes a slant asymptote. Actually, if it's 2 degrees bigger on top, you get a parabolic asymptote, an x squared asymptote. 3 degrees, you get an x cubed asymptote. It's shaped that way. We're only going to deal with lines, and all of them we give you will be 1 degree bigger. So 1 degree bigger is a slant asymptote, and to find it, we get to do our favorite thing. Find using division. Okay? Now, hopefully, we can use synthetic. But if we need to, we know how to do long division. Okay? Hopefully, synthetic division will work. So here's how it looks. If I give you a quick example and just say y equals x squared minus 3x plus 1 over x minus 2, bigger degree in the numerator, 2 and 1 in the denominator, so it has a slant asymptote. Okay? So the division, synthetic division, this is why we practiced it before, we put a 2 from the denominator up there. That's where the vertical asymptote is, at positive 2. We have 1, negative 3, and 1. Make sure you get all the coefficients. Drop it down, multiply, and add. This last negative 1, that is the remainder. It must not be 0. If it was 0, you had a factor of x minus 2, and you should have factored that out and canceled and found a whole. If it's negative 1 or anything besides 0, what that basically means is, remember we get close to an asymptote? The remainder is what keeps us a little bit away. It's not exactly equal to this line that we're going to get here. It's a little bit away from it. So 1 and minus 1, that is y equals, the 1 was x squared, so this is 1x minus 1. It's slope-intercept form already. So y equals x minus 1. There is our slant asymptote. So do synthetic division and just make sure you have a remainder and throw it out. And you get the equation of the slant asymptote. It gets close to that line. Let's do that with an actual example here. So we can factor this one, x times x minus 2 over x plus 1. So that'll help us find some things. Nothing cancels, no poles. Vertical asymptote, x equals, and negative 1 would be on the bottom, that x plus 1. So x equals negative 1. There is our horizontal. That's an x plus 1 to the first power. That means different sides on there. All right, the horizontal or slant, squared on top, first power on the bottom. That means bigger on the top, slant asymptote. Okay, let's find that using synthetic division. So we don't use the factored form for synthetic division. Go back to the original, set up your synthetic division. You've got a number in the box. You've got coefficients. So negative 1 from the vertical asymptote, 1, negative 2, and 0. Don't forget that 0. That's where the remainder is going to come from. And do your synthetic division. Find that slant asymptote here. All right, so hopefully you found the slant asymptote. Let's see, 1, negative 3. That's all we really need. Make sure you have a remainder. Check. Get rid of it. 1 and minus 3 means y equals, make sure it's a full equation, 1x minus 3, or just x minus 3. That has a slope of 1, intercept of negative 3. It's just slope-intercept form. So here's negative 3, and a slope of 1 goes right through these boxes here. So we are going to follow that as we leave the page. All right, x-intercepts, plug in 0. Look at the numerator. The numerator is x times x minus 2 equals 0. Don't worry about the denominator. 0 is the first one, but there's another one. 2, we have two x-intercepts. It's okay to have more than one x-intercept. One at 0, 0, one at 2, 0. Okay, that really helps me to find where this graph is. And the y-intercept, plug in 0 for x, and we have 0 on top over 1 is 0. That's same as 0, 0, same place. Doesn't really help us anymore. So we had two x-intercepts, no more, and that will help us with the graph. Let's see what we have. Well, each of these x-intercepts is first power, so we have to cross through at both of them. And we have to somehow follow these lines. So the only way I see to do that is if we do it this way. That one must go up, then cross through, turn around, cross through again, and follow out. It's the only way for that to happen. If we did it the other way, we'd have to cross through, then follow, cross again. So that's the only way for it to happen. Really, we're trying to decide top or bottom. Is it a kind of small angle? Or if we had points on the bottom, it'd be like a big obtuse angle kind of idea. Okay, but that's not where our points were. On the other side, same thing. Is it kind of the big obtuse angle here? Or is it the small acute angle? And we have plenty of information, even though we don't have points. First power here means if one side is up, the other side's down. They are different. So that one must be down here. We don't have any other x-intercepts, and if I drew the obtuse angle, you'd have to cross through the x-axis right there. Can't do that. So that leaves me with this one down here, and you could always plug in another point. xy, -2 is -8 when you plug it in. So -2, -8. So it's going to go right through there. And lean over and follow the other one. That just goes in a diagonal line, okay, or an oblique line if you want to use a geometry word. So there is our slant asymptote. We used our x-intercepts, we used the exponents on the direction and on the bounce wheel across. Everything worked out together. All right, so that finishes up 111, and 112 is just more practice with this, and that's what you have for this remote time. So this was the only video for this time. If you wanted to see the definitions again, I made a video for that with no pop-up questions, so you can just go and watch that whenever you want with the pop-ups. Make sure if you get it wrong, it will say retry. You should have at least 2 times to do the simple ones. And if you want to watch this video again, you can do that too. Okay. All right. Good luck with 110 from the class day. 111 and 112 is what you have for this weekend. We'll come back together. We'll see everybody. I'll see A cohort finally again and B cohort, and we'll go over a review of all this before we have kind of a cumulative test on all the things we've done since before the A group was quarantined. All right. We'll see you guys next time in class. Come with questions so we can get all of this graphing stuff reviewed. Bye.